Okay, so let's start. So in the previous session, we have already discussed about the TCP state. So, but there was a one diagram which was the pending. So I'm coming back to this diagram here. So now let's start here, guys. So in the previous class, we have discussed that actually by default, okay, let's consider these are the two devices and you have to establish a connection between these two devices. Okay. So before starting, to establish the connections, we have to always go with the three-way handshake process. So during that three-way handshake process, so many stages are there and so many states are there, which we have discussed in the previous class. So if I'm talking about before sending the sync or before starting all these things, what are the scenarios here? Let's consider this is a client. So if this is a client, so this is about, and this is the server. So before starting your any three-way handshake process, if this is a client, so means this is about what? This is active open here. And this is passive open. This is about passive open over here. These two concepts, okay? Active open and then passive open here. So see, this is about closed. Okay, in the closed, if I'm talking about this scenario here on this right side, okay, so this is about your active open concept here. Okay, and this side, the another color, this one, this is about your passive. So let's go through it. So see, first of all, we are always sending the sync. Okay, let's consider this is the client. And first of all, we are sending what? We are always sending the sync here. So when we are sending the sync, okay, after that, I'm expecting what? I'm expecting sync plus now. When I'm sending sync, okay, so I'm what? I'm actually sync sent. So when I'm sending, when I have already sent, if I have sent the sync, so the state is known as what? Sync sent. And now I'm expecting what? Sync plus active. Sync plus act. Can you see? Send, sync here. This state is known as sync sent. I'm talking about only active opener side. If on the another side, let's consider when I'm sending the sync packet here, okay, and after that I'm not getting any reply, and if your RTO, okay, if your timeout will be there, let's consider your timeout is there and now I'm not getting any reply, nothing is there, so again that connection will be closed. That connection will be closed. If there is a no sync plus act from the server side, so after that it will be goes back into, it will go back into which state? That will be in the closed state from here on. U-turn from there. When I'm going for the sync plus act, sync plus sent, okay, let's consider right now we have sent what? I have sent here sync, and now I'm in which state? I'm in the sync sent state. That is good. Okay, I'm in this state. I'm in this state here now. So from here, what are the things here? Two options are there. Two, okay? Two things. First, I'm going with this one here, A section here. A section saying, if I'm receiving sin plus act, so let's consider I'm receiving sin plus act over. So when I received sin plus act, so after that I have to send what? I have to send acknowledgement. And when I'm receiving acknowledgement for this thing, so now I'm in which state? I'm in the established. I'm in the which state? I'm in the established state. The same thing we have discussed in the previous class. Okay. So this is the same scenario almost. You can say closed, send sync. Now when I have sent the sync, so now my state is what? Sync sent state here. This is my state name. Sync sent. So from the sync send, now I'm in the sync send key. Yes, I have already sent the sync, and now I'm expecting what? I'm expecting send plus acknowledgement. So when I receive the sync plus act, so this act is about what? This is the act for the this sync here. And after that, I'm sending again what? I'm sending acknowledgement. And when I'm sending the acknowledgement, so now I'm from sync state 2, now I change it as a established. So means from sync to the established state. So this is the concept, this one. Is that clear or not? This is I'm talking about section this A here. But from the sync sent, we have one more option that also I'll discuss it. First, I'm talking about this thing. Any questions? Any doubt about this scenario here? No? Okay. The second scenario is that, okay, guys, we have already discussed there. in the three-way, when we are going for this connection establishment, okay, so there is a four-way handshake concept is also there. Four-way handshake. What is the four-way handshake? The four-way handshake concept is if both the devices, both the sides, they are sending the sync packet at the same time. So let's consider I have sent what? I have sent sync SYN, and this guy is also sent what? SYN. Got it? This is about what? SYN. So this concept is known as what? When I received SYN at the same time. So after that, I have to send acknowledgement, and this concept is known as what? Now simultaneously open concept. Is sync received there. See, if I'm talking about previously, if I'm going back, this is PC1, PC2 right now. Okay, so this is the listener. Okay, this consider send. So now this state is known as what? This is our what? Send. Okay, this guy will send what? Send plus act. So once this is a send plus act, this guy will convert from listen to the send received. That will be in the which state? Received. And after that, this guy will send acknowledgement, and this state is known as now established. This is the established state. So same here. Now, simultaneously, if we are opening, okay, simultaneously open means when four-way handshake process is there, send sync, and after that received what? Received sync. Okay, so then I'll be in the which state? I'll be in the sync received state. Okay, because as a this one as a passive opener, okay, I'll be in the which state? As a passive opener, I'll be in the sync received state. And after that, when I'll receive acknowledgement, after that I'll be goes into which state? In the established. Clear? We have one more concept here, that is about reset. Okay, that we will discuss today. We have to discuss about the reset. If we are getting the reset messages, what does it mean actually? Okay. And if I'm going with the passive side is first of all open. Okay, this is about always in the same listen state. Listen state, I'm receiving what? SYN. This SYN we are talking about. So when on the destination side we are receiving SYN, after that this guy will send what? SYN plus act. Can you see? Received SYN plus act. And when this guy is sending SYN plus act, this is about then the sync received. And finally, when I'm getting the acknowledgement, after that I'll be in the established. So you can see on the active opener, we have three stages actually overall. The first, close, second, and the third. But on the server side, there is the four states. First state is about close state, second is about listen, third is about sync received, and fourth is connection establishment. So on the passive open side, we have four different states. Sorry, guys. No, actually I got a call, so that's why. Okay. Now, so see this one in interview perspective, guys. In interview, they can ask you these type of things. Okay, the states, because during the debugging, the states always plays very important role there. Okay, because let's consider your connection is your TCP connection is going on, or maybe you are just trying to establish, and your connection is stuck on the sync received. So that knowledge should be there. Ki what is the meaning of the sync received here? Where actually I'm stucking? If I'm stuck in the sync received here, so it means I'm not getting any acknowledgement. So maybe there isn't some problem on the another side. Maybe another side, the device go down. Maybe so many issues are there. Maybe because of the conditions of the network, that thing means delay is happening over there. So many reasons are there. So then you have to find out, okay, what is the problem for that? Why we are in that state, what are the issues, and if some issues there, what are the solution for that. So all these things we have to find out. So from TCP debugging concept perspective, these state plays very, very important role. So if I'm coming back with this one, so we are on established here. Okay, we are at established side here. The thing is, now we have two different options from here. Okay, two different options. You can consider it as a client also, or you can consider it as your server side also. Anything you can consider, because the concept will remain same from the both the sides. What is this concept here? The concept is, okay, let's consider right now on the both the sides, connection is already established. The connection is established. Done. The thing is, the connection is data transfer is going on. Okay, data transformation that is going on there. Okay, no problem. The question is, okay, now let's consider on the both the sides. I'm talking about from this side perspective. We have to close the session. We have two options. Maybe I'm sending the FIN request. I'm sending the FIN request. Or second thing, I'm getting FIN request. Maybe two possibilities are there. Maybe I have to close the session first. So I'm sending FIN over there. And maybe I'm getting the FIN from the another side. So two possibilities are there. So about the two possibilities we have to find out. Same on the server side also. You can receive the FIN or you can send the FIN. So this is the same concept on the both the sides. So you can consider it as a active open also. You can consider it as a passive open also. Okay, up to you. So we will discuss about when we are sending the FIN request. So see, two options from here. Two options. The first is FIN receive, or second is send FIN out. If we received the FIN, let's consider on the client side, I'm receiving FIN first time. I'm not sending any FIN, I'm receiving the FIN. Okay, so when I'm receiving the FIN, let's consider connection established and we received what? We received the FIN here. So before that, I was in established state, and now I got the FIN packet, and now from FIN, I'm sending what? I'm sending acknowledgement for that. So when I'm sending the acknowledgement, I'll be in the which state? Send acknowledgement, receive FIN. I'll be in the close wait state. I'll be in the which state? Now I'm in close wait state. This one. Close wait is there. Now, next thing is what? This is done, FIN is done, one, this is done, second is done. Now it's time to send FIN for me. After that, this is known as half close also. This concept is known as half close also. Next is what? I'm sending FIN again. Okay, let me finish the session here. Okay, so send what? FIN. When I have sent the FIN, this concept is known as now last acknowledgement. Now I'm waiting for the last acknowledgement. And when you will receive the acknowledgement, so then we this is from passive close perspective. Okay, consider it, all these things are happening on the server side. Okay, you are a server. Consider it, you are a server, I'm a server. This is the server here. This is the client here. Now, connection is already established. This is established here. Now, first FIN packet. Okay, FIN is there. Let me acknowledge it. So this is known as close wait. This is close wait, no? Yeah, close wait here. After that, I'm sending FIN. Now, close wait to the last acknowledgement. And after that, I'm getting, and after that, it will be closed. Okay. Can you see? This is, after that, it will be in the last acknowledge. That's it. This is about your passive close here. Okay, because we have discussed now all these things. Passive, active open, active close, passive open, passive close. Okay. Next is if I'm talking about active close here. What is actually active close? So consider this is my client here, and now the connection was established, and now I'm sending what? Send pin. Now I'm sending pin. So when I'm sending the pin, okay, obviously I'm in the which state? Pin wait when state. Let's consider this is the client, and client is sending what? This is my pin. So when I'm sending the pin, so I'm in the which state? I'm in pin wait one state. Pin received, this guy is sending what? Acknowledgement. So on the another side, passive will become your what? Passive will become your close wait. Okay. When I received, okay, now received acknowledgement. When I received the acknowledgement here, then I'll be in the which state? I'll be in the pin wait to state. And now I'm waiting for the another side. After that, this guy will send what? This guy will send the fin. This is the fin. This guy will be in the which state? This will be in the last acknowledgement. I received the fin here, and after that, fin received, send the acknowledgement. And now I'll be in the which state? This guy will be in the time wait state. 2 MSL there. Okay. This is known as your maximum segment lifetime, which is 4 minutes for the your Microsoft server page. Okay. Just repeating here. One second. Connection established. This is the client. This is the server. Okay. Now I'm sending first pin. So this will be in the which state? It was in the established. This was also in the established. Now established 2, close, wait, 1. This is in the which state? Pin received, send acknowledgement. This is acknowledgement. So this is known as now, known as close, wait. When on this side, I received the acknowledgement. Now I'm sending what? Pin. So when I'm sending the pin, if I receive the acknowledgement, and after that I have to send pin, and now this state is known as close, wait, 2. And when this guy received the pin, okay, this guy what? This guy received the pin here, and after that it will be sends what? Acknowledgement. Close wait.
Sir, I think it's called fin wait, right?
Yeah, 1 second.
Yeah.
Receive this one, close wait, when send the acknowledgement, and when this guy sent the pin packet, it was in the what? This was in the close wait, and now this is the last acknowledgement. Okay, and now finally, this is the now pin on this side, and this is acknowledgement. Okay, and this will be in the timer state, close timer, and this is the finally in the closed state. And it will be the timer will be expired, that is about 4 minutes, and after that it will be in the closed session. These are the states. Okay. Now this is the very important from interview perspective. It's like a little boring. Yes, I can understand that thing. But yes, interview perspective, if you are applying for some higher positions and all, or maybe in security, because for the security guys, if we are applying anywhere, today I'll give you the list of the topics. What are the topics they are asking? Okay, mostly. So then you can, maybe if you're going for the Cisco, maybe Zscaler and all, always they are asking the questions from these things. It's not like they are not asking from the devices, they're asking from the devices also. Okay, for which team you are looking, maybe you are applying for the FTD, ICE, VPNs, depends on that. But before that, the first round will be always about basics, which is same for all the devices. Now, this is fin weight. This is about active close, passive close, initiator if passive close, if this is initiators and all, that's okay. Simultaneously close. Okay, so see, fin, send fin what? I have sent the fin. Fin is there, okay. Received fin also at the same time. So when I receive the fin, then I have to acknowledge it. See, fin from this side, okay, as a active opener I'm talking about. Now send the fin. When I have sent the fin, so I'll be in the which state? I was in the fin wait one state. Fin wait one state. Fin wait state, immediately at the same time, actually I'm expecting acknowledgement, but I'm receiving what? I'm receiving fin also, because this is about the same time. So I received the fin here. So when I received the fin, so immediately I'll be in the which state? I'll be in the closing state, because I received the fin now. Okay. So when received the fin, so for this fin, I have sent the acknowledgement, but now still I'm waiting for my acknowledgement. So finally I received the acknowledgement and I'll be in the which state? Time wait. And finally it will goes like this way. Once the timer will be expired, and this line, can you see about this thing? Finally, this is coming where? Coming to the. So again, we are coming from there. Again, opener, this one, the same concept is still. This concept, guys, this is actually, if I'm talking about this one, in the sync received, when let's consider it's happened sometime, okay, I haven't done that much R&D on this packet here, okay. See, on the both the sides, let's consider I'm a server and I'm as a active, okay. So what are the things here? The thing is ki I'm as a server, I'm as a client. So as a server, first of all, I'm in the which state? I'm in the listen state. So when I'm the listening state, so just consider this guy is sending a sync packet sending. Now I'm what? Listener, and I have sent what? Send plus ACK. So when I'm sending send plus ACK back, so I'll be in the which state? I'm in the send plus receive state. Okay, but immediately if I'm getting some fin packet, let's consider that guy don't want to go with the established statements and all. Okay, but immediately if some fin packet is there, directly you will come back with the fin wait state. So on this concept, actually, I haven't done that much R&D. I'm not sure about this thing. So please try to go through this concept yourself. Okay, in which scenarios we are getting closed send fin concept. Okay, so about this diagram, I haven't checked actually that much because I didn't get the time yesterday. So that's right. So please do the R&D about this one concept. In which scenarios we are getting this particular packet. Otherwise, I'll check it today and tomorrow then I'll explain. So this is about finite state machines case which we have discussed. So I'm done with the finite state machine. So if you have any questions, if you have any doubt, anyone, so guys, you can ask me. Anyone, any questions, any doubt? Okay. If one side is already down, so that Anjana connection timeout will be there. Keep alive, they will not exchange any keep alive. Okay. So then it will be closed automatically. There is nothing that will be, that error will be show you connection timeout. Okay. Because actually TCP also exchange the keep alive messages. That keep alive we haven't discussed up to now. So let's consider it's happened. Just consider there is a two sides, two clients, okay, and they are exchanging some data over there, okay. So when they are exchanging the data, and just consider now they have just stopped it. There is a no data transformation, nothing is going on, okay. So on that time they will exchange keep alive messages, okay. Let's consider this side goes down, and this guy is sending continuously keep alive messages, and then after that I'm not getting any acknowledgement from there. So that will be forcefully, it will close your this particular connection, okay. So on that time nothing is going to happen, because if you will try to will send pin or send something over there, you will not get any reply for that. So it will show you the error as a connection time. This will be the error for that, okay. Okay, can you repeat pin wait 2 again? Pin wait 2 is about when I received pin from the another side, okay, and I have acknowledgement, okay. See, this is, I was in the established state, sent pin here. I'm in the close wait 1. Close wait 1 here. Another guy is sending me acknowledgement. Now I'm in which state? Close wait 2. Okay. So now after that, when I'm receiving acknowledgement, plus I have to send pin now. Okay. Sorry. This is acknowledgement only. Sorry, not this one. Now from another side, this side, I'm getting pin. So that will be about wait state. Can you see this thing? When I receive the pin, oh sorry, this one. First send the pin. Now I'm in pin wait 1. Receive the acknowledgement, pin wait 2, and now I'm sending what? Pin packet. And when I'll get the acknowledgement, okay, receive the acknowledgement and send the receive the pin and then about acknowledgement. Clear? So this is nothing. This state. Pin. This is close state 1. That is the wait state 1. Received acknowledgement. And now this stage is known as 2 here. Okay. Third, I'm getting pin here. Now after that, this is the cold start with 2, and now I'm sending the acknowledgement. When I'm sending the acknowledgement, it will be in the is your close timer. Time out state. Received pin, send out. Then it will be the test state. Okay. So okay. Yes, one more thing you can say here. Pin wait state 2 is about your half open connection. You say I'm sending, okay, because I have sent the pin, I received the acknowledgement. So means from one side the connection is already closed. So half closed session. So on the another side still I have to send what? I have to send your, I have to receive pin. Okay, because from one side the from my side connection is closed. So I'm in the pin wait stage, because when we are doing the closing, so two type of closing, 2 times that closing is happening. One is from my side, another is another side. So it's when it's done from the my side, so then I'll be in the pin wait. And now I'm waiting for the pin packet from the another side. And when you will receive the pin, you have to send that, and directly you will be in the time. I hope it's clear now.
Yes, sir.
Okay. So after this, we are going with the reset here. TCP reset flag here. If we are talking about flags, okay, if I'll show you the flags there. So let me open that. That's one. Now, so if I'm open, if I'll open the flags here, can you see these are the flags here? Okay, these are the flags. So if I'm talking about the flags, so see, pin, we are done. You are aware about that. Sin, you are aware about that. Sin about that. Push, it's still pending. Push means when we are sending the data, but I'll explain that. Acknowledgement, the system. Now we have to discuss about reset, and we will discuss about the urgent. These two flags. Okay. Result, this is a not, this is a result guys. This is for the some future use. Nonsense. Nonce is also about some future use. Congestion and ECN. This is about some congestion control over. Okay. Once in your network, if some congestion is there, so and if you're sending any TCP data, so obviously we are like maybe you will get the acknowledgement little bit late over there. So how to handle that concept, that is known as congestion window in there. Okay, so during the congestion window, next topic is that only that we will discuss about these two flags. So right now I'm going to discuss urgent and I'm going to discuss push and the reset here. So these three flags I'll discuss today. Okay, and after that these things we will discuss tomorrow during the next topic. So after these flags, only 2-3 topics, the main concept will be pending. That is about, one is about options. Okay, that is will take, okay, options, congestion, and then keep alive. These three things will be pending here. That's it. Okay. Now I'm coming back with the reset message. What is the meaning of reset? Actually, reset flag used to indicate the connection problem, what happened, something unexpected like. Okay, let's consider some the thing is connection is going on, termination is going, okay, sorry, your connection is established and your data transformation is going on. You are sending the data, then you are getting the acknowledgement. So all these things are happening, that's going good. Okay, immediately this connection goes down, maybe just consider it in between that only. You haven't this is not intentionally, it's not closed because of some unexpected error or maybe because of unexpected event, like now this PC goes down. So on that time, what are the things over there? Then reset concept will be. Actually, reset has the three different ways over there. So many things over there. Okay. For the reset, actually, you can go with the one RFC. That RFC is about 793. This is the best RFC for your reset concept. The main thing, actually, I hope you have noticed actually in your BGP also this concept, because BGP is about your TCP based protocol. Okay. In BGP, if you remember, I'm not sure you remember or not. Let's consider this is the R1 and this is the R2. Okay. And let's consider you have configured BGP over there. Okay. And you have advertised networks also, everything you have done. And now BGP neighborship is not up still. Let's consider network you have to advertise, or maybe your neighbor you have advertised here. Who's my neighbor? My neighbor is this one there. Immediately this guy will send your type of like messages, okay, just to form the neighborship. Okay, now I have to form the neighborship. I think some open messages are there that I don't remember in the BGP. So there is a specific messages are there which we use to form the neighborship. I think that is some open messages, I think so. So those messages, immediately this guy will send the like that particular message over there. Okay, 1 second. BGP port number, let me find out. BGP port 179. BGP actually uses always TCP port 179. Let's consider you have configured BGP. My command is like about router BGP. AS number considered 10, and this is about 20, two different AS. I have configured 10 here. Okay. Then I have to describe who's my neighbor. Neighbor is my this guy. Okay. So when you will enable your BGP, immediately your port number 179 will be enabled, because this service we have enabled it. So now what you are doing, I'm sending the like message here to form the neighborship. The open messages I'm sending. Okay, hey, now I have to form the neighborship with you, and I'm from the BGP and my destination port. Because once you will send the messages, that message, open message, I think, to form the neighborship, then destination port will be your 179, because this is the BGP port number 179. So this is like this, Vicky, when we are sending here, but guys still here, BGP is not configured. BGP is what? BGP is not configured. Okay, if BGP is not configured, so obviously this guy is not aware about any key. What is the port number 179? I'm not sure what is that. Okay, because that is not configured yet. So this router will send back you reset messages there. TCP reset message. Reset message key, I'm not aware about that. You like this port number, what you are trying to communicate here. Okay, so means receive and sync message, because obviously first of all, before exchanging any type of messages and all, they will exchange the SYN packet here. So in the sync only, the destination port will be 179, because BGP always uses what? TCP, and TCP first what? Three-way handshake process. So when the first router R1 is sending the TCP SYN packet here as a destination port 179, and this service is not enabled on the another side, we will get the reply here as a reset message. You can try it yourself also today. Just use the two routers, configure the BGP on one router, and don't configure any BGP on the another router. Then you will receive reset messages. Reset message means this is actually, you can say, it will kill the connection. You know, that is not gonna be happen here because I'm 179. So on the another side, if you have opened your any TCP and all, okay, so that will be kill out, or that means that will be terminated. Okay, now forcefully I'm just terminating the reset. Means I'm terminating your connection there, because reset means try to reset. Reset, as you per name you can say reset, means started from zero again. Okay, in DOS attack or in DDoS attack, reset TCP attacks are also there, guys. There is a TCP reset attack. I'm not sure are you aware about that or not, but in the industry there is a TCP reset attack. Okay, so on that time what they does actually, let's consider there is a two clients. I'm just giving you example, and their just connection is established over there, and now you are an hacker. So what you will do, consider then you will send reset message, okay, behalf of this guy here, and reset message means kill the connection. You know, I don't want to keep any further communication with you. I'm just going to terminate the connection with you, and immediately will be terminate. This is forcefully connection termination. If we are using FIN, so that is a smooth one here. Okay, smoothly I'm sending FIN. I have to close the session from the another side. Okay, if you want to close it, okay, I'm also ready. Let's close the session there. So that is smoothly we are closing the sessions there. But this is forcefully if you are trying to actually reset, means ki once your devices went down, so on that time reset type of things are happening. That is an okay. But in this scenario, this is about as a attack. So now your connection will be terminate here, and after that maybe behalf of this device, this guy will make an TCP connection with the. So this is the type of hacking and all, okay. But TCP reset concepts plays a very important role for the hackers, okay. In a hacking world, they are using it as a type of advantage. Okay, this is type of advantage. So if you are not aware about this concept here, please go through your one topic in the routing and switching, that is known as hardening concept. Some hardening concept is there. So please go through your that hardening concept. Okay, then you will get to know. Even ARP is also in a type of, sometimes it's happened it will act as a disadvantage for us. Okay, and then GRP is also type of some type. This GRP has some disadvantage there. Okay, which will act as an advantage for an attacker there. So all those type of things you can study. Okay, so actually there is a thing there in 2007. Actually, this is about. I'm talking about on the US based thing. Okay, I was going through some case studies and all. So then I have seen all these things. Okay, in the 2007 in the US, okay, there was an ISP. That name I don't remember what is the name of that thing. So what was happening on that time? Actually, in the starting when internet started and all, let's consider this is a guy. Okay, it's any user, and this is one of the server, and this guy, and this is the ISP, internet service provider. So with the help of the ISP, first what this guy is doing, this guy is just now doing the three-way handshake process with this one, and directly connection between user and the server there. And now what user used to do, now they just used to download the files directly to this one here without knowing to the ISPs over there. So on that time when they started all these things, so ISPs and all that, they were in very lost on that time. Okay, so they just, okay, so what they did actually, ISPs and all, if some connection is there between two sites directly, and if they are trying to download some files, so they used to send reset messages. The reset message means now it will terminate your connection. And ISP used to say, ki, okay, don't download directly from the servers. What the ISPs were saying on that time, ki, we will provide you the one copy of the same server on the ISPs. Okay, we will provide you some platforms or maybe some spaces over there and download from there only. But for this downloading, you have to pay. This was free, okay, and for this one, it was a free. But after that, some like organizations came, so like about some FCC organizations are there. They came, and after that, they like because they were aware about all these things, and then some legal they took some legal actions and all like against the ISPs and all, and after that they did these things there. So right now, into this time, we are able to download any file directly from the servers, okay, without knowing any ISPs and all, because now this is end-to-end communications. Okay, so that is the things. Okay, after that, okay, because actually reset wasn't a very good thing, but ISP they were using according to their scenarios, so that's why. Okay, so this is about reset. If you have to terminate, mostly reset we are getting. One more example, what you can do right now. I can't perform, otherwise your class will be disconnected. And what is that? You can do one thing. This is your laptop here. Okay, we are connected with ISP, and let's consider try to download one file, one movie, or one song from YouTube or something there. When you're downloading will be start. So after that, do one thing, disable your NIC card. Once your NIC card will be disabled, so obviously this machine is down. Okay, so after that you can do one thing, you can start the packet capturing. Okay, so now what will happen from here? Okay, it will send the reset messages. You will get the reset messages. You can try this thing, disable your NIC and then enable your NIC again. So once during the between disabling and enabling between this time period, okay, your this PCs will send the reset messages. Okay, and again your three-way handshake will be there, and again it will be stopped. Okay. So these are the things about the reset messages here. Okay. So if you remember this thing, if you are going back with this thing here, so see this one. See, when I was in send received state here, okay, send received. Consider this is the send, send plus act here. Okay, send plus act, and now I'm in which state? I'm in the send received, sync received here on the another side. So in case, but now this is two-way handshake is done, and this guy is expecting acknowledgement, but at the place of the acknowledgement, maybe that connection has terminated, that device has got like switched off, or maybe something there. This guy is sending what? Reset. So when this guy is sending reset, so from the send plus received state, I'll go back in the listen state. Okay, I'll not is in the close state. I'll go back into which state? I'll go back into the listen state. This one. Okay, so in the your response to reset one, so this is I was in the C, this was in the listen state, device A was in the listen state. Okay, from here they sent what? Reset here, receive the reset, and now from receive the reset, and now again in the listen state. Okay, so these are some scenarios which I have made here. You can see device A, listen state, device B, send sync, receive the sync. Okay, after that, sync received state, now send reset here, receive the reset, and directly I'll come back from, first of all, I came from listen to sync received, and now the sync received to the go back again into listen state. Okay, so these are the type of things. Okay, so any another state, expect your sync received or listen. Okay, so if we are in the received state, okay, receive the reset, then immediately close it. So see, into this one, three scenarios. See, three scenarios. Consider I'm in the listen state. I'm a server, I'm in listen state, and I'm receiving here a reset message. So reset message, see, I'm in listen state only. I don't care about that if I'm getting reset or whatever, because it doesn't matter, because if nothing has started. So if I'm getting any reset message, the state will remain same only. Okay, I'm in listen only, no worry. Scenario number one. The scenario number two is, this is send here. Now I was in listen state. Okay, send plus. Now I have sent what? Send plus ACK. And when I have sent the send plus ACK, now I'm in which state? I'm in the send received. And after that, if I'm getting any here reset over there, reset if I'm getting, so after the reset from sync to receive, I'll go back to my listen state. That's it. Third state is that if your connection is already established, let's consider connection is already established. Accept your two stages. First is listen state, and second is send received. Accept these two states. If your PC is in any another state, then accept these two states there. Let's consider I'm in the established state. Okay, and I have received what? Reset here. If I received the reset, immediately from established to the closed directory. This is directly into which one? Directly into the closed one. Let's consider I'm in the established state here. Okay, and if I received any reset message on this time, so directly I'll be in the which state? Directly from here, I'll be in the, if I received it any reset, directly from established to the this state. That is about close. And I'm not going with this thing because this is not smooth closing here. This is the forcefully closed. So directly I'll go back to the close. Okay, so these are the state. This is about the reset. Okay, to terminate the sessions forcefully, then we have to use the reset concept. Is that clear? Any doubt? Any questions? Yes, just wait. I'm just coming, please. Wait one second. Okay, guys. Okay. Now, so see, next is about urgent pointer. Urgent pointer is also very important. Urgent pointer is about what? This is one of your like flag is there. This is, can you see, this is the urgent pointer here. Actually, urgent pointer and all these flags are actually, yes, see, we don't have to do with these flags manually anything. All these are the programmer based, okay? Because once the programmer and all, they are like uh, doing any type of, let's consider there's a programmer, okay, and he's just building some applications and all. So they has to take care of all these things there. So urgent pointer is type of the same thing, okay? Like we have to send the data urgently. Like first priority we have to give to the this urgent pointer. So if I'm talking about urgent pointer, okay, uh, so an urgent pointer, so the thing is, let's consider this is a PC1 and PC2 over here, and some connection is going on, or maybe something there. Okay. Now consider there's some, you are sending some data over there, okay, within this one. And let's consider you are just, this is some banking websites, okay, or maybe any banking application you are using, ICICI Bank or maybe SDFC or Citibank, something over there online, you are doing it. Let's consider you were doing some transactions and all, and after that you had just, your session was idle for the next 1 minute or 2 minutes, so automatically you now logged out from there. So after that, when we have to enter, let's consider there is a one TCB. There's this TCB is already ready, and in this TCB, consider some data is already there. And now after that, you have to log in here again. So when I'm just trying to log in, so I'm putting the username and I'm putting the password here. So see, actually in some books there is a mention this thing. When we are sending, let's consider this is the segment 1, segment 2, segment 3, segment 4. And these segments are already in queue to send to the destination sites. In somewhere, this is also mentioned, let's consider this is 4 segments out there, and after that 1 segment is coming with the concept of urgent pointer, and urgent pointer is 1 here. Because this is about what? You are just trying to log in onto some websites there, and this is about username and password. Okay, and username, password, this is my urgent data here. So actually this is your device is not gonna send, it's not like that. Your device will keep all these segments in a queue and then it will send first this one and after that these things there. No, that is not there actually. You can go through the RFCs. There is so many like 1 or 2 RFCs are there. I'll give you the what is the RFC number. So actually before that even I was confused. The urgent pointer means first it will send this header, this segment, and after that it will send all these things. But it's not like that way, guys. Okay. So the thing is actually it will send it into the same normal manner here. If this segment number is 5, so it will send it after the segment number 4 only. Not like that in the starting only it will send it. No, it's not gonna happen this thing. So then question is, if it will send it in the normal manner, so what is the meaning of the urgent pointer here? Actually, urgent pointer plays a role on your receiving side, not from the sender one, not on sender side. Okay, what does it mean actually? The thing is, see, urgent bit, 2 things we have, urgent bit and urgent pointer. Urgent pointers, the size is about 16-bit here. This is what? Now, this is type of urgent pointer is in a type of flag actually. Okay, the same thing. Actually, see, what is the thing? Let's consider this is one server, okay, and I'm on this server and this is the client. I'm already sending or maybe I'm downloading so much data over there, and so many segments are considered. These are some segments. Segment 1, segment 2, segment 3, segment 4. 4 segments are already there, and now this is my 5th segment, and this is about urgent. This is about urgent. So urgent bit, 2 things, your urgent bit and urgent pointer, both will be 1 1 on that time. Okay. In which scenario the urgent pointer will work actually? This will work when we are using the username and password concept. Okay, this is the best example for the urgent pointer scenarios. In which scenario do we use it? This is in the scenarios of username and password. When we are trying to enter or when we are trying to log in somewhere, so we have to send username and password, and that authentication should be happen at the first priority, but not from the sender perspective. Let's consider it's reaching on the receiving side. When we are sending this urgent pointer here, so into this one, this flag will be act as a like urgent pointer. This is a flag, consider it flag here. Once this data or once these segments will reach on the destination side, this server will check it. Okay, once it will be comes here, this server will check it the data. Okay, this is the data over there, because when your data is reaching on the server side, server CPU always gives the some time to the device. Okay, please go through this type of data. When the segments are coming, please check all these segments here. Please try to read the data. So when CPU will try to read the data, it will check it. Okay, this is what some urgent data is there. Urgent data means, because flag is what? Flag is up, urgent flag is there. So this data is urgent. So on that time, this device will be entered into your urgent mode. It will be entered into urgent mode. Before that, it was in the normal mode. But when your CPU will see, okay, some urgent pointer is there. So urgent pointer is on and this is here. So it means some important data is there. I have to process first this data. Okay, so on that time, this device will first process this particular packet. Okay, let me check it. What is this one? And I'm in the which mode? I'm in the urgent mode. So in urgent mode only, it will check this particular data. Okay, some username, password is there. I have to authenticate, and after that, it will send the reply. So once it will be done, after that, it will come back from urgent mode to the normal mode. And then in the normal mode, it will process all these packets one by one. Like in segment number 1, segment number 2, segment number 3, segment number 4. Like this way, this concept will work. Any questions? Any doubt? Urgent pointer is plays very important role again for the interview perspective. Okay, so that's it. So if you have any questions, if you have any doubt, so please ask me. No. Okay, so this is the concept of, and in exams, okay, sorry, in the interviews, they can ask, okay, if as a server, if I'm getting any urgent bit or urgent flag as a on means 1. So what are the things? So first of all, this server will like change its mode from normal to the urgent mode. TCP will enter into which mode? It will enter into your urgent mode here. Okay, so then it will first process your that urgent segment here where your flag is on, and then it will start the processing for that. Okay, this is the one concept. In one more book, that what was mentioned there. Okay, from sender side, both the books were correct actually, but if I'm talking about on the sender, on the receiving side, let's consider what was the thing on that. Two segments are like these are the segments. Segment 1, segment 2, segment 3, segment 4, segment 5, and this is segment 6 here. And this is urgent now. If this is urgent, okay. In the second book, what they have mentioned actually, the author name I don't remember right now, what that guy has mentioned, he actually right now I was in the normal mode here. When I'll see the flag, okay, in this window, one segment is there with the name of urgent here. So on that time, what it will do, it will enter into the which mode? Urgent mode here. And when it will enter into the urgent mode, on that time, the CPU processing will be double on that time. Maybe before in the normal mode, let's consider in the normal mode, if your CPU is taking 5 seconds to process 6 seconds to process the 6 segments here, in urgent mode, it will take your 2 to 3 seconds. It means processing speed will be increased. Okay, some urgent pointer is there, so let me finish all these processing faster, and then I'll reach to this one. One book was saying if it will give the first priority to this one. one book was saying it will goes one by one, but the processing speed will increase on that. Okay, and then it will reach to the normally in normal mode, maybe to reach up to 6 segments, it will take 6 seconds, say, or 6 milliseconds I'm talking about. So, but in urgent mode, it will take 2 to 3 seconds. Yeah. So this is the faster this one. And once this urgent pointer will be proceed, means the processing is done. After that, it will be come back from, it will change its mode again, urgent to the normal. And after segment number 6, whatever the segments are there, S7, 8, 9, 10, it will go with its normal speed. So there are the 2 scenarios are there, 2 things are there, okay? Even, okay. So that you have to also find out which is correct actually, but these are the 2 concepts, okay? But in RFC actually, this concept is mentioned. RFC, okay? So that's something R&D you have to also do. And once you will be verify and once you will be confident, so just let me know as well. So there is a 2 scenarios for the urgent pointer. One is one by one it will go and it will give then the processing speed will increase during this time up to your this urgent pointer here. Okay, this is the first thing. Second thing, and the first is it will give the first prior to do this one, it will process it, and after that it will go back. Okay, so there is a 2 scenarios for the urgent pointers. So there's a one RFC for that. That RFC also, if you want to go with that, you can go. Yes, guys. Any questions? Any doubt? Okay. The next thing is what? The push. The thing is push point flag. What is the push? Push is nothing. Normally when we are sending the data, let's consider first of all SYN plus ACK, and this is acknowledgement. SYN plus ACK, and this is acknowledgement here. So after that, when we are sending the data, so to send the data over there, we are using one flag over there, and that flag is known as push flag. So means first this is about push, and then after that again we are getting the acknowledgement. So this is about push means when we are sending the data. So up to now we have discussed these following flags. First is about SYN, then about acknowledgement, then about ping, then about urgent. After that it's about push and about reset. Okay, some nonce is there, that is about your future use. One experimental is there, that is also for the future use. 2 more flags are there. One is the ECN, and one more flag is there. What's his name? One is ECN, echo, and this is about CWR, congestion there, CWR. So this is again one more, and these 2 things we have to cover during the congestion control concept. Congestion control, these 2. Okay, so in the next class we will cover the 2 topics. One is about TCP options, okay, and the second thing we will cover the congestion control. First of all, we will discuss what is the congestion, but to how to control this congestion, we have the 3 things over there. One is the slow start. Mostly TCP this is by default enabled. TCP use always a slow start. One is the fast recovery, and one more thing is a fast transmit something. So there are the 3 options for the congestion control. This is theory based. So in the TCP option, almost in the TCP option, if I'm coming, so in the TCP options, we have already covered MSS. We have already covered. Okay, W scale, window scaling, we have already covered. SAC, we have already covered that. So what are the major things? Major things is about TCP AO authentication and TCP authentication, user timeout, UTO, and 1 or 2 more like options are also there. That also we have to cover. So hardly these things are pending. Okay. So in the next class, we will cover TCP options and we will cover this concept. And after that, one more half an hour session that is about keep alive, or I'll try to cover keep alive on the same day if it's possible. And next class will be, guys, day after tomorrow, because tomorrow we have some meeting actually. It's near about 1:30 something. So tomorrow the session will be not possible. So next TCP session will be on day after tomorrow. Day after tomorrow. Okay. And day after tomorrow, what is the day? That is on the Wednesday. The time will remain same, 2 p.m. And on the same day only, I'll try to finish the batch. And after that, if you will be interested and all, then we will start with the SSL Friday onwards. Or Wednesday, Thursday onwards. Thursday onwards, we will start with the SSL. Depends on you.
Okay, sir.
Maybe I'll cover on Thursday or Friday, we will cover DNS. DNS is also DNS or FTP. Okay, we can cover these two things also. Okay. So, okay guys, so then see you day after tomorrow, not tomorrow, and on to day after tomorrow, we will finish the TCP. I don't want to stretch it on the Thursday as well, because keep alive messages, this topic is for 15 to 20 minutes, not more than that. Okay. So because MSS, these things we have already covered. So I have to cover these 2 or 3 things. We'll take 15 minutes this one, 1 hour for the congestion control, and 15 minutes for this one there. So hardly 1.5 hour session, and that easily we can finish. Okay. So guys, then see you day after tomorrow. Bye-bye. Take care. Have a nice day. Okay guys, thank you.